It's pretty easy to see why, because it has the word sine in it. That's just the general category for any cos or sine graph. They're called sinusoidal. And that just means that they have that constant max-min. They repeat forever. It's got that wavy kind of pattern. They all fall into the same category of sinusoidal. So definition, a periodic graph I put on hand lotion, now my pen's slipping out of my hands. A periodic graph with continual, that does not look right, continual, that looks better, maximum and minimum values. A periodic graph with continual maximum and minimum values. So it has that idea of waves, constant up and downs, hills and valleys, we sometimes call them, mountains and valleys. And so here's what we call just a general sinusoidal equation. It doesn't have to have sine in it. It can have cos. And we call, I can't get the cap off my highlighter. There we go. And we call the transformations A, B, C, D. Why those letters? No reason. They're just variables. And so A is that number outside brackets in front. It's outside brackets, so it's vertical. It's a multiplication, so it is a vertical stretch. But more importantly, a vocabulary word we talked about last class is it's the amplitude of the graph. It's the amplitude of the graph. Does anyone remember what the word amplitude meant from last class? Make it bigger, yes. Definition was the center of the graph to any max or to min. So it's the center of the graph to the maximum. It's the height of the graph. It's called the amplitude. So you can actually get it right off the equation. Whatever the number is front, that's the amplitude, because that's how much we stretched it. So it went from 1 unit to whatever we happen to stretch or compress it. B we talked about before is a horizontal inside multiplication, stretch or compression, right, depending on the number. Now, there's a few things in math we're really picky about, and there's a few things in math we're pretty lazy about. So we talked about under a square root. We're pretty lazy about putting the brackets. We're also pretty lazy with brackets with sine and cos functions. There's actually brackets here that we never tend to write, because we know if that B is tucked in there that it's horizontal. But just in terms of what we've talked about so far, that's why it's inside the brackets, is because there's brackets there that we don't really tend to write. So if A is the amplitude, what was that other vocabulary word that we talked about that went with amplitude? I said there was 4 things we're going to talk about with trig functions: amplitude, something, domain, and range. Anyone remember? Period. So this is kind of the period, but kind of not the period. We say that B equals 2 pi divided by the period. 2 pi divided by the period. And that comes straight from the horizontal stretch or compression, because we're dividing the normal period, which is 2 pi. We talked about that, just the same as 360. And we're dividing it because it's a horizontal stretch. What was C? So inside brackets, and this is addition or subtraction. Horizontal translation. Here's a fancy term. In terms of sinusoidal equations, it's called the phase shift. The phase shift. That's why we call it phases of the moon, because that's the shift along the time. When does it happen? Well, there's a certain date. When does the next happen? Another certain date. So it's just a horizontal translation. Number at the end, outside the brackets, all by itself at the end is vertical translation. And we call this the center line of the graph. The center line of the graph. Knowing that, what it allows us to do is just look at an equation, so not the graph, and we're going to be able to say what's the amplitude, what's the period, what's the phase shift, what's the center line, just by looking at the equation and not having the graph in front of us. Okay, so first one is 3 sine x plus 4. How do you know this is a sinusoidal equation? It's got a sine or a cos in it. The minute you see a sine or cos, it falls under the category of sinusoidal equations. So we're going to identify the amplitude, the period, the phase shift, the center line. Number in front, that's always the amplitude. So we say the amplitude equals 3 units. The period comes from the b value, and the b value is tucked in between the sine or the cos and the x. We don't see it, but there's actually a number being multiplied there. What's tucked between the sine and the x? It's a little imaginary 1 in there. So we say that the period is 2 pi divided by that little imaginary 1. And what's 2 pi divided by 1? 2 pi. So this has what we call a standard period, because there's no horizontal stuff happening in this graph. Period comes from 2 pi divided by that b value. In this case, it's 1 because we don't see anything. The phase shift comes from the c value, which is always the number with x in brackets. We don't have a number in x with brackets, so what's the phase shift? It's 0. That just means we have no horizontal translation going on. And the center line is the equivalent to the vertical translation, so the center line is always the number at the end all by itself, and the center line in this case equals 4. Why do we need to know this? Because we're going to use it to graph in a second. Okay, let's do one with a cos. Again, doesn't matter if it's sine or cos, they're all called sinusoidal. We grab the number in front, it's the amplitude. Now you need to be careful a little bit when there's a negative, because the amplitude is a distance. It's a distance from the middle line or the center line to a max or to a min, and a distance can never be negative. So we never say an amplitude is -2 because it's a distance. So you'll see sometimes in the book they'll talk about the absolute value of A or the absolute value of the amplitude. What does absolute value mean? It takes away the negative because it's a distance. So you'll sometimes see absolute value of A, that's all they're talking about. So the amplitude here is not -2, it's 2 units. Okay, so you might just want to make yourself a note, don't include the negative or take the absolute value, whatever makes sense to you. Amplitude is a distance, so it can't be negative. We could. So sometimes you'll see it'll say like this, absolute value of -2 equals 2. Yeah, I just did it in our head, but you can write it absolutely. The period comes from the value that's tucked in between the cos or sine and the x, and the period is 2 pi divided by that value. So we're going to do 2 pi divided by 1/2. How do we divide fractions? Oh, the silence. We take the bottom number and flip it. Take the reciprocal. So this is going to turn into 2 pi times 2 over 1. 2 pi times 2 is? Two pi times 2 is 4 pi. Which should make sense because what that number represents is a horizontal stretch. So we have grabbed this graph and we've stretched it, so we've made the period of the graph bigger. The phase shift comes from the number in brackets with x. Do we have a number in brackets? So phase shift equals 0. The center line comes from the number way at the end all by itself. Do we have a number at the end? So what's the center line? 0. What that means is it's right on the x-axis. Okay, amplitude, period, phase shift, center line. Amplitude is always that A value, the number in front of the sine or the cos. Do we have a number in front? We do, we just don't see it. What's the number we're multiplying by in the front? It's 1, so it has what we call a standard amplitude. The normal cos and sine graphs have an amplitude of 1. The period comes from 2 pi divided by the number tucked in between sine or cos and x. In this case, it's 2. 2 pi divided by 2 equals pi. That just means we've taken the graph, we've squished it in, because we know this is a horizontal compression. The phase shift comes from the number inside the brackets with cos, and we change the sign because we always know that plus is to the left and minus is to the right. So if this is plus 3, we know the phase shift is negative 3. And that's just like saying 3 units to the left. And the center line is the number at the back all by itself outside the brackets. We don't have one, so the center line we would say is 0. Questions so far on those 4 things? We're going to use those a lot today in next class. Okay, amplitude, period, center line, phase shift. Okay, now we're going to go backwards. I'm going to give you some properties, and we're going to write the equation that has this property. So we're going to write a sinusoidal equation that has an amplitude of 3, a period of 2, and a phase shift of 2. Okay? So sometimes for left brains, what I like to do is just write those little letters above. Amplitude I know is that A value. Period I know is kind of the B value. What's the correlation between the B and the period? 2 pi divided by the period is B. The phase shift we said was C. And center line I don't have, so what do I know automatically about that center line value? It's 0. Okay, some brains that helps to list it out, sometimes it doesn't, it just depends. And then what I like to do is just write out the general equation. Again, you don't have to, but sometimes it just helps to fill in those numbers. So we have A, sine or cos, doesn't matter which one you use. B, open a bracket. X plus or minus C, doesn't matter. And then plus D. Okay, so that's that general form of the sinusoidal. Do we have an A value? Do we have an amplitude? Yes, what is it? So I'm going to put a 3 in front. Do we have a B value? Well, we've got 2 pi divided by the period, and the period they give us is 2. So 2 pi divided by 2, pi. We have a little pi tucked in there. Do I have a phase shift? And if it's positive 2, what happens in the equation? It goes to negative 2. There's an equation that has an amplitude of 3, a period of 2, and a phase shift of 2. Common mistakes. What your brain is going to want to do, it's going to want to put a 2 right here, because you're just going to see period of 2 and you're going to sub it in. You need to remember that B represents 2 pi divided by the period. The other thing with these is it just says write a sinusoidal equation. It doesn't say the sinusoidal equation. Let me give you another one that has the exact same properties. I meant to put a 3 here. That's another correct answer. Okay, let's talk about why. What did I do here? At a negative, and does that change the amplitude? No, that's just a vertical reflection. It's just flipping the graph. It's not changing the distance. I change cos. Does that matter? Do I still have a period of 2? Well, 2 pi divided by pi equals 2. Do I still have a phase shift of 2? So just because you have one answer and the back of the book has something different doesn't mean yours is wrong. There's always a bajillion different questions, different answers you can give for these. Okay, amplitude of 4, that's that A value. Period of pi, okay, that's got something to do with B. What's the relationship with the B in the period? 2 pi divided by, in this case, pi. So the B value is going to be 2. Vertical shift, sometimes they'll use that instead of phase shift or center line, so you just need to be aware which is which. If it's vertical, is that our phase shift or our center line? That's our center line. That's our D value of negative 2. What about C? Don't have one, and that's okay. Sometimes we don't. Okay, so using our general formula here, I can have 4 or negative 4. It doesn't matter because those both represent an amplitude of 4. I could have cos or sine. Doesn't matter. I'm going to put cos just for fun. B is the 2, which is tucked in between the cos and the x, or the cos and the theta. I don't have a c value, so I don't need any kind of brackets. And what gets tagged onto the end? My minus 2. Here's another possibility. Does it matter if I put the negative? No, that's got nothing to do with the distance. That's just a vertical reflection. Can I put sine instead of cos? Absolutely. What did I do here? Can I move a variable? Sure. I can put x, I can put theta, I can put whatever I want. I still have an amplitude of 4, I have a period of pi, and I have a vertical shift of negative 2. Standard amplitude. What the heck does that mean? Yeah, well, if you think of it just a regular cos or cos or sine graph, what's the highest point at? So this just means an a of 1. Okay, that's what standard amplitude means, a value of 1. Okay, b is kind of the period, but not quite the period. So I've got 2 pi divided by 2/3. So I need to do a little bit of math. So 2 pi times, what do I do with the 2/3? Flip it, 3 over 2. To multiply fractions, it's just top times top, bottom times bottom. So 2 pi times 3. And on the bottom, 1 times 2. And then we just reduce. What's 6 divided by 2? So I have a 3 pi as my v value. Turn to someone and write the equation. Write an equation together. Okay, y equals. What do I put for a? Oh, I froze, thank you. Nothing, but mathematically we know what's there, the one that we don't see. So the first thing I'm going to start with is, yeah, imaginary 1, and then sine or cos, your choice. Sine tends to be the favorite. What comes after the sine? And then an x or a theta, no brackets. Why no brackets? Because we don't have a c, and plus 4. I could also have negative cos 3 pi x plus 4. I could have sine 3 pi theta plus 4. I could have tons of different possibilities here. Questions so far? Why do we need to know this for questions like this? This is really what we want to do today. Is imagine we had some kind of data. Maybe it's the sunsets of Winnipeg, and we want to figure out what's the formula because we need to predict the next sunset. All we have is a graph. We have to take the graph and we have to make an equation. That's the point of what we're doing today, is how do we take this and write the equation that goes with it. So this is like backwards transformations. Imagine this is the final. What did you graph? What were all the transformations you graphed? Questions so far? Just going to highlight it actually asks for 2 different sinusoidal equations. That's because we could have a sine, we could have a cos, we could have lots of things going on. We'll talk about that in a second. I'm going to go to the method first, since you guys usually want to do that before the question. So number 1, we're going to decide on a base graph, which I'll tell you how to do that in a second. Second thing is we find the center line. There's a little formula. Then we're going to figure out what is D, A, B, and C, and there's a reason I've put them in that order. And then we're going to write the equation. Same steps will work every single time. There's no exceptions. These will always be the steps. Decide on a base graph. There's 4 basic shapes we can have. We can have a basic shape that starts at the origin, goes up, comes through that center line and goes down. So we call that a max and a min, or sometimes a mountain and a valley. What base graph looks like that? So what starts at 0 and ends at 0? That's a sine graph. That's our 0, 1, 0, minus 1, 0. Well, what if for some reason my data went the other way? What if it still started at 0, but it went down and then up? What base graph is that? It's not cos, because cos we know starts at 1. This still starts at 0 and ends at 0. All I did is I went down instead of up first. Well, in terms of reflections, what is that? That's just a vertical reflection. This is y equals negative sine theta. Okay, that's a base graph that goes down before it goes up. It's just a vertical reflection of sine. The third one, I might have some kind of data that starts up at the max, goes down to the min, and goes back up to a max. What graph starts at its max and ends at its max? That's cos. The fourth possibility, and you'll see next class, is actually the most common. It's the one we see most often in the real-life applications. It starts at the bottom, goes up to a max, and returns down to the bottom. What base graph is that? It's negative cos. So when we do the example, I'll explain what it means by mark the endpoints. But that's the first thing you do is you decide what base graph do I want to use? Which of these ones do I want to start with? The second thing we do is we calculate that center line. And what we're really doing is calculating smack in the middle of the graph. So the formula is a max plus a min divided by 2. Center line is the average of a max and a min. So the reason I do the D, A, B, C in this order is because D is the center line, so we've actually already done it in step 2. A represents the amplitude. Definition of amplitude is a center line to a max or center line to a min, so all we do is count. So distance from center line to a max or a min. We just look at the graph and we physically count the number of units. And for right brain people, I'm just going to add an arrow because this is a vertical distance, so we're always counting up or down to find amplitude. And you'll see in a second why I made that distinction. B is the one that's related to 2 pi, so it's 2 pi divided by the period. And that's 2 pi divided by the distance between maxes or distance between mins. It doesn't matter, it'll be the same. The distance between 2 maxes or 2 mins. And that's a horizontal distance we're measuring. And that C is the phase shift. First time I taught this in the notes, I forgot the F in shift. Just saying. And how do we count that? Is we look at the distance from the y-axis to our start point, which I'll explain when we do the example. It's the distance from the y-axis to the start point. And the last step, we just take that ABCD and we shove it into the equation. It looks complicated. It looks like there's lots of stuff to remember. You're going to see after we do a couple examples, it's going to be very repetitive. It's the same steps every single time. Grabbing my pencil because I'm going to end up erasing what I'm about to do. Is anyone else obsessed with having a sharp pencil? Can't stand the minute that point goes, I can't stand it. Two different sinusoidals. So the first thing you want to do is mark 2 points, and it's completely up to you where you put the points. I want you just to watch me, and I don't want you to write. I could choose to start my graph here and end my graph there. Why did I pick that? Because that's the top back to the top. If I chose that, take a look at the shape you see. Which one of our 4 base graphs starts at the top and goes back up to the top? That would be a coast graph. That would be one possibility. Maybe I'm like, no, I don't feel like doing a coast graph. Don't really like coast. I like sine better. That was the worst erasing ever. Maybe I'm going to start down here at a min and end at a min. Maybe I like that one better. So take a look at your base graph as which one starts at the bottom and ends at the bottom. Sorry. Which one starts at the bottom and ends at the bottom? That would be a negative coast graph. That's a second choice. Maybe I'm like, no, I don't like that. I want to start smack in the middle, and I want to end up at the middle. So take a look between those points. Which one starts at the middle, goes up, and goes down? That's a sine. Maybe I'm like, no, I'm not thinking that one either. I'm going to think like way outside the box, and I'm going to start right here, and I'm going to extend my graph and go back to the middle. Possibility. Which one goes down and then up? That's a negative sine graph. I could find a million different base graphs, and they're all going to be right. It's completely up to you. So I always say go with what your brain sees first. If your brain sees the up to the up or the highest point to the highest point, go with that first. If you see low to the low, go with that first. Because we need to do 2, we're going to do the same 2. So I'm going to tell you the first one. We're going to go max to max. That's what step 1 means, is figure out where do you want to start and where do you want to stop, and you want to mark those endpoints. And then I usually just make myself a note. Which base graph was that? Which one goes top all the way to the bottom, back to the top? That's a coast graph. Okay, so I like to write that down because I'm visual. Just as a reminder later, that's where I chose to start and stop. Now I need to do the center line. Center line is the average of the max and the min. So I'm going to look at here. What's my max value? So we're looking at the y-axis. Where does the max value start? -2. And if I look down here at the min, where is my min value? So the center line just comes from averaging those 2. And if you can see it, you don't need to write down the formula. I'm just showing you where it comes from. It's -2 plus -4 divided by 2. So halfway between -2 and -4. And you can probably see that's -3, but let's just prove it. -2 plus -4 would be -6. -6 divided by 2 is -3. And because I'm visual, I like to actually draw it in. And I'm drawing it with a dotted line because it's not really part of our graph. It's just a visual representation of where that halfway mark is. If you're not visual and you don't need it there, don't feel like you have to. Now what we need is that A, B, C, D. I always start with D because we just found it. D we know is the exact same as the center line. It's -3. So that's why I always start with that one first. Amplitude depends on the center line. It's why I do it second. And an amplitude is the distance from that center line to a max, or a min, or the next max. It doesn't matter. This is your A value. It's the distance from the center line to a high point, or center line to low point. How many units between -3 and -2? 1 unit. And because it's positive, because it's a distance. B value is 2 pi divided by the period. And the period is from a max to a max or a min to a min. So we're looking at the horizontal distance between these 2 values. This is the period. Okay, horizontal distance from min to min, max to max, center to center, doesn't matter. And so if I go up here to my x value, we're looking at 1.25-ish. And this one looks to be 4.25-ish. So how many units between those? 3. So my v value is 2 pi divided by 3. The c value comes from the distance from the y-axis to the first starting point. So all we want to know is how far did we shove this graph over? How much did I push it horizontally? That's just the horizontal translation. So this is where your c value comes from. It's how much from the y-axis to where we started. And this to me looks like 1.25, a little bit past 1. I should just mark the center line, sorry, is where D came from. So D is that center value, which is just halfway. A is the distance from halfway to a max. B is 2 pi divided by the period of the graph, which is max to max, or min to min. And the C value is from y-axis to where it started. Now I'm just going to put it into my equation. The A value comes first. I'm going to write the imaginary 1 just so when you look back you see what we did with it, but know that we don't usually write it. I'm going to write cos, because we chose to do a cos graph. My b gets tucked in between the cos and the variable that I'm about to put. I need a bracket because I have a c value. X, theta, whatever you want, minus 1.25. And I'm just going to pause. Why was this minus? Because it's positive here, it's to the right, and we know that the right ends up being negative. And at the very end is my d value, negative 3. There's my first sinusoidal equation. There's how to go backwards. I will, yeah, in a second. Okay, it asked me to write a second one, so I'm going to choose to cut at the center line and then back to the center line. And I'm just going to highlight this for visual people because you might get mixed up with the other graph. This is now the section of the graph I want to look at. Did I have to choose those? No. I could have chose a min to a min. I could have chose lots of things. I just chose center to center because I want you to do a sine graph. So I'm going to do it right beside. I'm just going to change colors. Okay, center line is still the exact same way, min, max, divide by 2. Minimum value, so I'm looking at this green highlighted one. Minimum is negative 2. Sorry, maximum I should say. Minimum is negative 4. What's the new center line? Exactly the same. Center line didn't change. Amplitude is the distance from the center line to that max, or center line to min, whatever. How many units between negative 2 and negative 3? No, it didn't change either. The period, or the b value is still 2 pi divided by the period. Period is still the starting point to the end point. So I'm just looking at my starting point here. I look to be about 0.5. And over here I'm 3.5. So how many units between 0.5 and 3.5? Oh, 3. Oh, that didn't change. And the c value comes from the y-axis to the starting point. So how much did I shove this little guy over? So we said that was roughly 0.5. What's the only value that changed? That will only be the value that ever changes when you go from a sine to a cos. Because a sine is a cos graph, it's just been horizontally shifted over. We didn't stretch it, we didn't move it up, we didn't squish it in. C is the only value that will ever change when you're writing your second equation. I'm going to repeat that. C is the only value that will ever change when writing your second equation. So if the book has a different answer than yours, you should still have the same A, the same B, the same D. It's just your C and your sine or cos might be different. Everything else will stay the same. So our second equation, okay, again a 1 that we know we don't need. Sine, because the second one we cut at a sine graph. 2 pi on 3 is still the B value. Going to open a bracket, put a variable. Negative 0.5, close the bracket, and then negative 3. Show me your thumb so far. Kind of getting there. Good. Practice some more. I think this is our last one for today. Oh, no, 2 more. We want a sine and a cosine equation for the graph below. How do you know a graph is linear when you look at it? We started with those way back in grade 10. How do you know a graph is linear? It's a line. How do you know a graph is quadratic? Show me. Show me what a quadratic looks like. Nice, nice. People drawing in the air. Now we've added this year. How do you know when a graph is cubic? Yeah, it's the snake through the origin, right? How do you know an absolute value? Show me absolute value. It's the V. How do you know a square root graph? It's the swoop. How do you know a sinusoidal graph? The up-down, right? Up, down, up, down, up, down. That's how you represent a sinusoidal. You'll know when you see it because they're the funky ones like this. We're going to do exactly what we did last time. We got to pick a starting point and an end point. Go with what you see first. My brain goes from a max to a max. It's just what I see first. Because not everyone thinks the same, let's do a negative cos graph just for fun. So let's cut the bottom of it. How do I know that's a negative cos graph? Because it starts at the bottom and ends at the bottom. So I always remind myself this is a negative cos graph. So when I come back, I see it that I've got to put a negative cos. Center line, which is really the D value, we go from a max. Okay, so what's the highest value we have? 9, I heard someone say. And the lowest value? 3. So the D value becomes 9 plus 3 divided by 2. 9 plus 3 divided by 2. And I like to draw it because I'm visual, and it reminds me, if I can draw it correct, that it's halfway. Sometimes when you go to draw it, you're like, that's not halfway, and it's just a reminder, then your center line is off. I always do A next because A is linked to D. What is A? Well, it's the amplitude. What's the definition of amplitude? Center line to a max, center line to a min. Doesn't matter which one I do. I'm going to pick the middle one just for absolutely no reason. How many use from our center line to our maximum point? Offer of 4. Ooh, correction of 3. B comes next, and it's 2 pi divided by the period. The period is your starting point to your end point, so the distance between these two dots. And so we're looking now at the x-axis. The first dot is at 2, 2.5, I think is a little bit better. And where's the other dot? 5.5, so how many units between them? 3. So I'm just going to write down where we're getting it from. So we took 5.5 minus 2.5. You don't need to write that work there, I'm just showing you. So 2 pi on 3. And the C value is always the hardest. It's always one that people struggle with. It's the y-axis to where we started. The y-axis to our first starting point. Okay, how much did we shove this over? Okay, so it's a negative cos graph, so it just means before my A value I'm going to throw a negative in, so negative 3. then cos. I almost put the theta in there. Lefties understand my need to white that out. B gets tucked in the middle, so 2 pi divided by 3. Open a bracket. Theta x, whatever you want. I'm going to theta it up. Why not? C values in brackets. Why is the C value negative? Because it's to the right. And at the end goes. There is a really common mistake, and that's a half mark off on the exam. What did I forget? Yeah, you need to have it equal to something because it's an equation. Okay, so don't forget at the beginning that y equals. Okay, we got to do all over again for a sine equation. Sine starts at the middle and ends at the middle. It's completely up to you where you cut it. I'm going to do a negative sign just so that we've seen all 4 base graphs. So I'm cutting it at that middle line, then I'm going down, then up back to the middle line. Did I have to? No, I just chose to cut it there so we'd have a negative sign.
Sorry for the interruption. All students that are involved in the press conference during period 2 this morning, if you could please make your way to Mr. Evans' class 2C5. Thank you.
What's the D value? 6. How do we know it's 6? Because it's exactly the same. What's the A value? How do we know it's 3? Because it's exactly the same. What's the B value? Because it's exactly the same. C is the only one that's going to be different. What's the definition of C? Y to the starting point. So we just need to know how much did we shove this guy over. Offer of 2, 1.5, I think it's in the middle a little bit. So y equals, what comes first? Negative 3. And that's why I write the base graph here, because if you don't write the negative, you're going to tend to forget it down here. Have fun. Sine. Yes. There we go. Last one. Find a friend. I'll give you a couple of minutes. Just note the question that it says sine. When the question says sine, it wants a negative or positive sign. It means you can't have a cos anywhere. I'm feeling like you're ready-ish. Again, you might not have the same answer because you may choose to cut it somewhere else. I'm going to cut it the first over here and the second one over there. Okay, you might have chosen right here to the end. It's completely up to you. I've chosen a positive sine graph. How many people picked the same points? Okay, even if you didn't, your A, B, D will be the same. It's only your C that will be different. Okay, center line. Heard 0? Amplitude. Offer of 3. B value, 2 pi divided by the period. Period's from here to here, which is 2 pi and 25. C value, how much did we shove it over? Now we're just going to put it in. So y equals, first number is, followed by, followed by, followed by. X, theta, doesn't matter. And nothing. Nick. Center line to a max or center line to a min? Fight it out. You good? Who had the exact same? Awesome. Anyone has something different that they want me to check? We're good?